Good morning, everyone, and thank you for joining us today. My name is Kelly Timko. I'm from Galarath, and I'll be your moderator for this event. Welcome to 9 proven ways to reduce mission cost and 3 approaches that never work. Today, we're featuring Dr. Christian Smart. We know you're busy, and we appreciate that you're taking time out of your day to learn something new with us. All lines have been placed on mute, so we don't have any background noise. So if you need to have any help or if you have any questions, you can use the chat function to speak with me. Today's training is brought to you by Galarath. Galarath is the leader in analytical program management, empowering analysts and organizational leaders to make complex business decisions with confidence through the use of predictive analytics. And on the web, you can find us at galarath.com. So I have a few announcements before we begin. Please stick around for the live Q&A period at the end. This will be your opportunity to ask questions and make this session directly relevant to you and your organizational challenges. We'll also be providing a link in the chat window to a 2-minute post-event evaluation survey. And this is important so that we can understand what you found valuable during this webinar and also what you want to learn in the next Lunch and Learn session, what topics you'd like to hear. The link to obtain the PDF version of today's presentation will also be provided at the end of the evaluation survey. And on next Thursday, we'll be giving away a $100 Amazon gift card from the pool of survey respondents. So go ahead and take a moment to fill out that survey and get those things. Also, if you're from a government agency and you won't be able to accept a gift certificate, we're also happy to donate that amount to a charity should you be selected. Also, if you know of anyone else in your organization or on your team who should be joining us this morning, you can ask them to join us right now. Just send them a link to galarath.live. That's GALORATH.live. And you can also sign up for our next training session at galarath.live. And that's going to be November 16th at 10 a.m. Pacific. The presentation is going to be called How to Diagnose a Doomed Proposal, What Not to Do If You Want to Win. So please join us for that. Today's training is also being recorded and will be available for later viewing on demand. We'll send the URL to everybody by email within 7 days. So if there's anyone in your organization who had a scheduling conflict, couldn't be here, please feel free to share that with them. Okay, so today's presenter is Dr. Christian Smart, Chief Scientist of Galarath Federal. Dr. Smart has 20 years of experience with cost and schedule risk analysis, predictive analytics, probabilistic reliability analysis, and machine learning. And his background in aerospace includes missile defense programs, nuclear thermal propulsion, hypersonics, and robotic and crewed space vehicles. So with that, I'm going to turn the presentation over to Dr. Smart.
Thanks, Kelly. So you've seen the title, so we'll go to the next slide. And Kelly's talked a little bit about me, so we'll skip that slide as well. I'm going to talk now about what you're going to learn today. By the end of this webinar, you'll understand that projects often cost too much, take too long, and they're also very risky in terms of resources. They can also grow in cost quite a bit, and they expand in schedule quite a bit. Talk about why these issues occur. In all likelihood, your project is no different. The bulk of this presentation will be on ways to effectively reduce costs. If you're an analyst or a program manager or working on a project, you've probably seen this issue time and again, and there are some simple and effective ways to reduce mission costs. We're going to discuss 9. Now, simple does not mean it's easy. If you want to, for example, if you want to lose weight, it's simple. You just consume fewer calories than you burn. Sounds very simple, but as we all know, it's harder to implement in practice. We'll also discuss some things that don't work. There are 3 techniques that are very appealing to organizations. On the surface, they are very appealing, but they do not work in practice. We'll discuss those. First, we'd like to talk about the issue, which is that projects cost too much. They take too long. Here, for example, there's a famous example in recent history is the $10,000 toilet seat cover. In 2018, the Air Force paid $10,000 for a toilet seat cover on an airplane. They could have potentially 3D printed it for a few $100s, saved a lot of money, but it cost way more than it should have. This is an extreme example, but it's not atypical. It's high cost, long schedules, and underperformance of the norm for projects. They also experience, not only experience high costs, they also experience significant cost growth and schedule delays. There's a variety of reasons for that. One is the optimism bias, the planning fallacy. Projects tend to be optimistic. Psychologists have discovered that when we plan for the future, we don't plan for the worst case or even the most likely case. We plan for the absolute best case. It's also the idea of prospect theory, which is if you are faced with a loss, you are more likely to, you're risk averse, you're more likely to take a risk or risk seeking in the face of losses. So you're more likely to take a risk if you're faced with a prospective loss. And in terms of when it comes to project analysis, many projects, especially public projects, have limited upside but significant downside in terms of cost growth and schedule delay. So project managers have a tendency to want to seek risk and throw the dice and gamble in an attempt to try to take on more risk when it comes to achieving savings that will not likely be realized because they're taking actions that are not likely to pan out. From Augustine, who coined a series of maxims called Augustine's Laws about project management, he referred to the Las Vegas factor of development program planning, which is basically you take the planned cost for a program, multiply it by 1.52, and on average, that will be what it turns out to be. And that's pretty much the case for any type of defense or aerospace project. That average cost growth has been the same for many years and decades. For example, the cost of schedule growth across all industries is a legacy disaster. It's very common. It happens all the time. It's high. The average is high. And there's extreme cost growth in many cases. For NASA and DoD, for example, more than 1 in 6 projects more than doubles in cost. You can read more about that in my book on solving for project risk management. Next, I want to talk about, we need to make some changes. And one of the changes is that, we need to make is we need to realize that we need to do things differently. So projects continue to cost more, take longer, and deliver less capability than they should. And we're never going to change that or break that cycle if we don't change some things. A couple of quotes that come into mind here are, insanity is doing the same thing over and over again, but expecting different results. It's been attributed to a variety of people, including Einstein, but it likely seems to come out of the 12-step program type process. And you can imagine with addiction, this would be very applicable to that. If you want to break the cycle of addiction, you have to do things differently. Another somewhat entertaining maxim is if you've do what you've always done, you will get what you've always gotten. And educator and counselor Jesse Potter coined that. So the point is we need to do things differently to reduce cost. And here's kind of an overview of the 9 ways to save, and we'll go into each one of these in detail. One is competition. That's a very simple idea. Don't rely on a single source, get multiple bids. If that holds true whether you're trying to build a rocket or an airplane or you're just trying to get your house remodeled. You should get multiple bids. You should also structure an acquisition so you're not locked in long term. And we'll talk more about what that means in a little bit. We need to use incentives. Use incentives in contracts to get tasks accomplished earlier, which can lower costs. We'll provide an example of that. Number 3 is simplify. Wherever possible, choose the simplest solution that meets your goals. Choose those over more complex ones. 4 is establish realistic baselines. An important factor is the lack of risk management, which we've talked about earlier. Number 5 is cost as an independent variable. We need to trade off cost versus requirements to avoid the extreme high cost of basically gold plating. Number 6 is use proven technologies. We need to either use proven technologies in time and proven configurations. So if we use proven technologies in new configurations, we could go back down the technology readiness curve. Or you need to take the time to mature the technologies before you start development in earnest. And if you do, and that's not always the case, that you can't avoid doing something new and novel. NASA is in the business of doing cutting edge research. The Department of Defense is often in that realm. a good example of that is hypersonics. That's very cutting edge technology. But the key there in terms of reducing costs in such programs or trying to contain costs is the notion of one miracle per program. And that comes from Lockheed Skunk Works, which was famous for producing aircraft at relatively low cost and quickly. And they would often do complex things, but they would do them iteratively. And so they would make one improvement on each program. And at the end of several different programs, they would have a very capable vehicle that has several novel technologies in it. But by limiting themselves to one miracle per program, they were able to contain their costs. And one of the handouts that'll be available at this course is a series of maxims from the longtime leader of Lockheed Skunk Works, Kelly Johnson. His 14 maxims. Many of those would apply to all types of projects. Number 7, reduce reporting. Cut back on the paperwork. Maybe harder to do, but if you're using a vendor, you should put less burden on them, and that does save money. That is a big difference in the cost between government and commercial approaches to developing and producing all types of projects. Number 8, reduce testing where you can. It's always the case that you can. You don't want to completely cut out testing and take on too much technical risk, but many times products are over-tested. You can, where you can, cut down on your testing. And there are other ways that you can get this problem without doing physical testing. You could potentially do simulation in lieu of some testing. But regardless, reducing testing will save money. Number 9 is seek out of the box solutions. To achieve radical cost reductions, you really need to look at novel ways to lower costs. Try to think beyond, you need to be creative, just think beyond traditional solutions. Okay, so we'll go over each one of these 9 in detail. The first one of these is competition. When you're looking for vendors, get multiple bids. Organizations often sole source work to proven providers, but this can be more expensive. If you use a cost plus contract, it can provide more savings, but you take on more of the risk on your end. With fixed price contracts, the price can be higher since whoever you're contracting with is taking on more risk. But studies have shown that for cost plus contracts, competition can save around 10%. When you get in the bids, if you look at the bids on competitive contracts, they tend to be about 20% lower than sole source contracts. And sometimes in order to win the work, the companies will bid too aggressively, and then the costs will grow. And you will see that happen on cost plus contracts because you're the one that winds up paying the overage. But studies have shown that the real savings is around 10%. Incentives. Put incentives in place to save time and money. It's a proven way to achieve better performances. Here's an example of a road project in Huntsville, Alabama, where I live now. By using incentives in the contract to finish early, and there are also penalties for finishing late. There was a $30,000 a day penalty for finishing late. The project finished a year ahead of schedule. And shorter schedules can lead to lower costs because of large amount of fixed costs. So putting incentives in place can work. It's proven to work. Potentially achieve the savings, though. Some risks may need to be taken. So there's no free lunch here. Simplify. There's an urban legend that NASA spent millions of taxpayer dollars to develop a space pen. And when they went and talked to the Russian cosmonauts, they said, hey, look at our fancy space pen. They said, oh, that's great. We use pencils. It's not exactly true. Both NASA and the Russians use grease pencils in space. And the Fisher Space Pen Company actually developed the space pen using their own money. And they then sold the space pens, both NASA and to Russia. But NASA and Russia still use grease pencils as well as the space pens. But there's a good point in this urban legend, which is to keep things simple. If you can use a grease pencil, why go out and develop your own space pen? Simple designs reduce the number of subsystems, components, and interfaces, and that flows through to all aspects of the project. If you combine that with an increase in design margin, this can increase the confidence and performance and reduce your needs for redundancy. And reducing your redundancy needs can save money because you're developing and you're buying fewer parts. So simple designs have potential to save big money. Simple spacecraft designs, for example, have been proven to save up to an order of magnitude compared to traditional approaches. There are some examples out there where organizations have saved significant amount of money by using simple approaches. Realism. We need to wake up and smell the coffee. So we need to establish realistic baselines for cost and schedule. Standard practice is to be optimistic. That's very prevalent. What that sets up is the cost growth and schedule delays. A better alternative is to have a realistic baseline that offers a smaller chance for cost growth and schedule delays. If you try to budget, say, for $500 million, but a realistic number is $1 billion, a budget of $1 billion is much more likely to come in closer to $1 billion than an initial target of $500 million is likely to come in at $1 billion. When you set up the program up, not giving enough money, you're likely to grow back to the $1 billion. And then because of the problems that occur, because you're not planning for enough money in advance, you're going to have funding constraints. That's going to lead to schedule delays. You may wind up having to cut scope. In the end result, you're going to have less capability and it's going to cost more than $1 billion at the end of the day. So by being realistic up front, you can save some time and money compared to optimistic baselines. And a key part of that is getting independent input, getting independent estimates that are not tainted by project management optimism. Next, I'm going to talk about CAVE. CAVE is an acronym. It stands for Cost as an Independent Variable. It's a variety of names, but basically it means trading your requirements against your cost and sometimes your schedule. The bitter truth is encapsulated in Augustine. We talked about Norm Augustine earlier. Augustine's 15th law, in which he stated the last 10% of performance generates 1/3 of the cost and 2/3 of the problems. So by backing off just a little bit off of the high end of requirements, you can save quite a bit of money. It can provide you a sweet spot. What is the least costly set of requirements that still meets your objectives? And I have a curve there that's taken from my book that was published last year. Another way to save money is to use proven technologies. The technology readiness level is measured on a 1 to 9 scale. And it measures the readiness of a technology. And it comes from NASA, but it's used across a variety of industries, the Department of Defense and in other organizations. There are specific rules for the adoption of technologies in government agencies, but these values are consistently overestimated. That is, or an organization will say it's a TRL 789 when it's actually a TRL 345. Even if you use a proven technology, but if you put it in a new configuration, it can result in new challenges. For example, I worked on the Constellation program years ago, which was planning to take a solid rocket booster that was similar to one that had basically been used in the shuttle program, but then they were going to add a segment to it, which added a set of complexities. And then they were going to put astronauts on top of that segment, which had never been done before. And as a result, they discovered during the development process that there was a potential for an oscillation. There was an oscillation issue that would be set up that by putting people on top of the small, skinny rocket, the tall, skinny rocket, you would have this issue of oscillation, which basically would be like a shaken baby syndrome, except this would be in an adult. So it'd be like shaken astronaut syndrome. Their brain would be turned to mush because of the oscillation. So they had to go back and do some design work to prevent that from occurring. The project was eventually canceled, partly because of issues like this, where they were trying to use some proven technology, but in novel configurations, which resulted in a significant underestimation of the amount of technology development needed to be done. What's the graph that's there on the right is some studies have been done to talk about the change in TRL delta, the cost to improve the TRL or increase the TRL during development, and how much additional cost is required. So if you have to increase the TRL from a 3 to a 6 after you start developing a program, you're gonna more than triple the cost. So this is a huge cost growth, a huge driver of cost growth, and something that you definitely want to avoid. So you want proven technologies, and you want them in proven configurations. And that's very important. If you're changing the configuration or you're doing something new with it, you have to be very careful about that. And if, like I said earlier, it's not always the case that you have the luxury of just doing the same old, same old. Many times you're trying to advance the state of the art, do something new. And that's where the Lockheed Skunk Works maximum of one miracle per program, one technological advance per program. Just focus on that and then iterate. Many projects try to advance state of the art in multiple areas. A perfect example of this is the James Webb Space Telescope, which is about to be launched soon. It's taken a long time to develop and costs a lot of money to build. If instead they focus on one advancement per program, this is kind of the incremental approach, which has also been adopted for software development as part of the agile approach. That can definitely help save costs. And so it's just one miracle per program. Take it in increments. And like I mentioned, Lockheed Skunk Works follows this approach. Let's talk about reporting requirements. Many projects, especially public ones, have significant reporting requirements. But many commercial firms have streamlined and reduced reporting. The difference is that by having very minimal and zero reporting requirements, and the studies have been done on this, that can save 50%. Just the amount of reporting requirements can reduce the cost by half. The caveat is, depending on what you're doing, there may be some amount of reporting is necessary. For example, if it's a government project, it's important to get cost reports on what the project actually costs. Another key factor in this is keeping the requirements fixed, not changing the requirements, not just reducing the reporting requirements, but not adding on new requirements to the project. Or not requirements to report, but also reducing the number of requirements that you have. Another way to cut costs is reduce testing. It's an important part of validating a design, but it can be expensive. Dropping down on testing where you can reduce your cost by 20% or more. But you cannot arbitrarily cut testing without undue risk in many cases. But you should look at the requirements. Don't over-test. And another factor that can help reduce testing is if you have simpler designs that have significant design margins, that can offset some testing. And you can also potentially offset some amount of testing by using simulation. Another key thing is you want to think outside the box. Take another look. Don't look at just what's been done in the past. Be creative. For example, it's common to focus just on development costs and trying to cut down on development costs, because it could be the case that you could save money longer term in operations by investing some time up front today to make the system operable and maintainable. But it's cheaper to forego that investigation up front. So you really need to look at the entire life cycle. For many missions, the majority of the life cycle costs are in operations. When this is the case, that designing a maintainable system up front can save money long term. You need to look at the whole picture, not just be myopic and look at just what's in front of me. If I'm in the development project, I need to look outside of just that. I also need to change the paradigm. So we talked about earlier about one miracle per program. The Hubble Space Telescope costs billions of dollars and 25 years to develop it. And if they were just to increment the different pieces and the different advancements that went into Hubble, one step at a time, that could have saved time and money. It'd been, a few $100 million spacecraft versus a multi-billion-dollar spacecraft that could have achieved similar objectives to Hubble over the long term, cost less time to deploy than Hubble. And a similar approach could have been done potentially for James Webb Space Telescope as well. I've got over on the right a series of dots, and this is called the 9-dot problem. So it's an example of thinking outside the box. If you look at the 9 dots, the challenge is to connect the dots by using straight lines and not lifting your pencil off the paper. What's the fewest number? Well, if you just think about it, you stay within the box. The smallest number is really 5. You can start with the top, go down, go all the way down to the bottom left, go all the way across to the bottom right, back up to the top right, back up to the middle top, and then back down 1. That's 5. But if you were to draw the lines outside the box, you can do it in 4. So thinking outside the box, drawing lines outside the box, you can reduce it. I'm not going to go through the solution here, but if you're interested, you can Google the 9 dots problem, and you can see that, and you can see how to draw with only 4. Okay, we've talked about 9 ways that can save money, and they're realistic. There are 3 other approaches that projects often try to undertake that never work in terms of saving money. 2 of these typically cost at least as much, if not more. One may save some money, but may also be much more expensive. So the number 1 I've listed there is concurrent design. Trying to do more at the same time can create risk and can be a recipe for disaster. You have to be very careful about that. And particularly if you're trying to overlap development and production. Schedule compression. Shorter schedules can save costs, but artificially compressing a schedule is the costliest action a project manager can take. It's actually going to lead to significant amounts of cost growth and schedule delays. So, it's one of those cases where if you're taking actions that legitimately can cut schedule, that's logical. Many of the 9 things that I talked about will result in saving some time. Simplifying the design, using proven technologies. Those kinds of things naturally reduce the schedule, but just trying to take a schedule that should take 3 years and trying to do it in 9 months is a recipe for disaster. So that's what we're talking about here. Number 3 is reuse and off the shelf. The tempting approach is to assume savings due to reuse or plans to use off the shelf hardware, but we always overestimate this. This is a prone to optimism. We fail to take into account the changes that will need to be made or the integration costs. I worked on a project where I'll give more detail about that in a minute. And we're going to go through examples here of each one of these, or we're going to a little more detail on each one of these. So concurrency is doing things at the same time. So for example, if I do 2 tasks, I do one after the other, then the amount of time taken for the 2 is the sum of the 2, 1 plus 2. But if I can do them both at the same time, then it's the maximum, whichever one takes longer. So that could potentially save time and money, but it's easier than it looks. Doing more things in parallel is easier than it looks and can increase schedule and cost risk significantly. It's so significant that the Government Accountability Office has highlighted this as an issue and has stressed that when they look at audits of projects, they look at how much concurrency is in the schedule. They look specifically for this issue. And a famous example is the Joint Strike Fighter, which is the F-35. They experienced significant cost growth and schedule delays for both development and production. An important reason is that after flying one non-production representative aircraft, the project entered production. So it's smart to reduce testing where you can, but in this case, the project went too far and come back on the testing, and that led to issues because they were trying to produce a system that was not flight ready, which meant that they had to do more development and more production work than they should have. Schedule compression. Shorter schedules can lead to lower costs, but haste can make waste. So, that's an old expression, is haste makes waste. Artificially compressing a schedule after a project begins is the costliest action the project can undertake during a project. It's to try to artificially compress it. Shorter schedules can mean less cost, but to achieve them, you have to plan for it up front, and it needs to be realistic. It needs to be in phase with how you're planning to actually get things done. It needs to match the scope of the project. Okay, let's talk about reuse and off the shelf. So reuse is overrated. So projects often try to save money by claiming heritage from prior programs. Well, we're going to use this part that was used on this tank, or we're going to use this radar, or we're going to reuse this. And that's not necessarily a bad idea. Again, you want to rely on things that worked in the past, but you need to account for the changes to the planned reuse. And you need to consider the challenges of integrating off-the-shelf parts and the software. A UK Ministry of Defense study concluded that COTS software, which is commercial off-the-shelf software, is often more expensive than developing it yourself. I worked on a software project years ago where the organization I worked for had purchased a a black box off-the-shelf solution for doing a critical part of the calculations needed for a computer-assisted design software. And a lot of the geometry calculations were done by this black box software. They kept trying to get us, the code that I was working on, kept trying to get us to optimize the code, make it run faster, make it run faster. There's only so much you could do because the black box software was not very efficient and ran slowly. And the amount of time that had to be efficiently be fit into the black box system, and it ran in and did its job, and it came back out. There's only so much you could do there. And the project wound up being canceled as a result of the fact that we were relying on a piece of software that we could not manipulate and we could not fix the issues with to make the software run efficiently. So kind of the three things that I want to kind of summarize here are three key success if you want to save money on a project. And I think we all want to save money on a project. We make better use of resources and make our projects more successful. If you're in the private industry, you'll make the projects, you'll be more profitable. If you're in your public life, you can make more efficient use of taxpayer dollars. So regardless of what sector you're working in or where you're working in the project, we all should focus on that and try to save money. And the three keys to success are: consider the 9 methods that I've talked about. There could be more. There could be other things out there that you could do, but at least start with those. And as a result of this, people that register, you'll get a list of these things summarized. Avoid the pitfalls. Avoid trying to do too many things concurrently, compressing schedules, and too heavy reliance on off-the-shelf software to save significant amounts of money. And another thing is, I've got a cup of coffee there. Wake up and smell the coffee. Which is an idiom that basically says be realistic. You got to do things differently if you want to be more successful. And so now it's time for our Q&A session.
All right, thank you, Dr. Smart. So our hope today is that everyone has learned at least one new thing you can immediately put to use in your organization. So I hope you have found something that's useful. And before we dive into the Q&A session, I want to remind you that the PDF version of today's presentation deck will be available at the end of the 2-minute post-event survey. So please take time to look in the chat window for that survey link. I'll be posting that in the chat window. And you'll also have a chance to enter whatever other future topics you'd like so that we can present those in future Lunch and Learns. We won't be using the hand raise function for the Q&A. We'll only be using the Q&A button. So please just type in your questions there. We will also be using the upvote feature. So that means that everyone can see all of the questions. And if there's a question relevant to you, you can just put a thumbs up and give it an upvote. That way you don't have to retype the whole question yourself. So with that, we're going to go ahead and open up the Q&A portion for Dr. Smart. So let's see. Okay, so do these approaches work for all types of projects, and what about agile projects?
Yes, these approaches work for any type of project. Agile is a great way to, as we mentioned in this talk, a great way to approach structure of a project. It's often applied to software, but that incremental type of approach applies to any kind of project. But these principles apply to any type of project. Agile is just one way of structuring the project and trying to do things in a better way. But these apply to any type of project in any industry, commercial, public, any type, construction, spacecraft, tanks, roads.
Okay. Which methods offer the biggest potential savings?
Thinking outside the box is a very big one. The organizations or the cases where I've seen projects save the most money is by doing things radically differently. In terms of if you want to try to save an order of magnitude in terms of cost, 89%, you got to do things radically differently. Simplifying designs is a big one. And reducing reporting requirements. If you are an organization that has a lot of layers of bureaucracy, cutting out some of the reporting requirements can save significant amounts of money.
Okay, thank you. Which of the pitfalls is the worst in terms of potential impact on cost and schedule?
I think the schedule compression is the costliest action of the project. can take, especially after a project has started. If you've planned for a project that should take 6 years and now you're trying to do it in 6 months, it's a recipe for disaster.
What are other things that organizations can do to help ensure success?
Pay attention to risk management. Taking into account risk management is a key one. We talked about all the issues with cost growth and schedule delays. That's evidence that projects have a huge amount of resource risk, but also the fact that they're not managing that resource risk well. So a little bit of attention to risk management can pay significant dividends.
Okay, let's see. Are there any signs to look for when reviewing unrealistic program cost and schedule plans?
You need to look at what the assumptions are in the scope and look at similar past projects. Some sort of independent estimate would be key to that. Looking for a basis of estimate. If a project does not have a cogent basis of estimate that you can say, oh, well, okay, it makes sense. Their basis is this. That's a warning sign.
Okay. Let's see. Sorry. When performing risk management, how important is it to perform a cost risk analysis that informs a more generic risk management method, like the risk cube?
A quantitative cost risk analysis should be done for any type of project. A generic risk management method tends to significantly underestimate the amount of risk. So to really get your hands around, understand the true extent of risk that's involved, especially with the resources, you need to do a quantitative cost risk and a quantitative schedule risk analysis.
Okay. Here, is there a quantifiable metric that relates design and development cost reduction to the use of PDM systems as well as system modeling software?
I don't know of a specific metric that would relate those two. That's a good question. I don't have a good answer for that one.
Okay. How about this one? How would you incorporate high variety of possible subsystems, suppliers into a system cost model?
If you are competing a contract, you can take into account some potential savings for competition, around 10%. If the legacy data that you're basing it on, or you're doing something differently from what you've done in the past, if all your data is based on competitive systems, then there's probably no savings. But if what you've done in the past is that you had a sole source vendor for several years, and now you're going to compete a contract, or you're going to compete a particular vendor or a particular subsystem, then you can potentially, maybe see 10% savings.
Okay, thank you. Let's see, here's another one. How to model cost advantages or disadvantages of modeling previously designed subsystems from an earlier program versus designing the subsystem from scratch?
Yeah, so you can do that parametrically. I've done it in the past by including a variable for the percentage of new design, which can range from 0% to 100%. And you can model that as a variable in a parametric model.
Okay, thank you. If there are any other questions people have, don't forget to please type them into the Q&A. And I have put in the chat the link for the survey. So please look at your chat for that link and take a couple moments to answer that.
I think I see a few more in the chat too. Which of these is most valuable for reducing schedule? And that is key. It's a great question. Simplification of design would be a good one. Would be one of the key ones, reducing schedule. There's another comment. The worst cost driver I found was changes in requirements. That is a significant increase, like a significant thing that can cause cost to increase. There is a famous example of a project that came in about half the cost it was initially planned for. It was a missile defense experiment that was managed by Michael Griffin, who some of you may know. He was formerly the cost director of NASA and more recently the Undersecretary of Defense for Research and Engineering. He managed a project where I think it's called the Delta 180 project that delivered at half the initial plan cost. And one of the key factors for the success of that project was keeping requirements stable and not changing requirements. So yes, keeping requirements stable is very important. Having realistic requirements and then keeping them stable, not changing. That can be tough to do. It's easier said than done because we live in an environment where our technology is growing exponentially. This is called Moore's Law, right? The amount of transistors that you can put onto a semiconductor doubles every 18 months or 2 years, something along those lines. People have been predicting the end of that for some time, but innovative scientists continue to find ways to keep it going. You pair that with projects that take years and even decades to complete. You have a little bit of a conundrum. Do you keep the requirements steady and potentially deliver an obsolete product, or do you try to chase the evolution in technology, and that requires changing the requirements. So that can be easier said than done, but keeping requirements steady can help you cut down on cost growth.
Do you have a few more questions in the Q&A too?
Yeah.
The next one is, what is the best time to incorporate DTC? Is it ever too early?
Oh, design to cost, and it's design to cost. Now, it's never too early to incorporate design to cost. The best time to do it is early, early in the planning stages. Doing these kinds of things up front early on will have the biggest impact. It's just like, trying to steer the course of a ship. If you point the ship in the right direction when it leaves port, it's a lot easier than trying to change. It's a little easier than trying to change course midstream, right? So,
okay. Here's another one. Do you recommend reviewing a program C and SRA methodology as well as reviewing the analysis results?
Yes. Yes, you should. It's a great question from Maximilian. Yes, you should look at the analysis. So you should look at what an organization did to produce their point estimates of cost and schedule, which do not have any risk associated with them. And then you should also review what their risk analysis methodology was. There are all sorts of issues out there with risk analysis, and many times organizations and analysts tend to underestimate the true extent of risk. And so you need to watch out for that. So yes, that needs to be reviewed. It's important.
Okay, thank you. I have a comment and a question. This next one. So number 6, use most proven technologies is a good rule of thumb. At NASA Flight Research Center, we often are taking TRL 1 through 3 and increasing the TRL level to 5 through 6. Oftentimes our projects slip their schedule due to the integration phase. What would you recommend to the project manager who is trying to improve the new battery technology for the new eVTOL vehicle?
Well, try to improve the technology up front before trying to incorporate it in the development phase. Try to do some sort of technology development project up front.
Can you give a 1 to 2 sentence difference between DTC and the CAIV? Okay.
Design to cost. So So to design to cost, you're trying to develop a design that will fit a specific cost bogey. So, how many, if I've got $100 to spend at the store, how many, what kind of groceries will fit within my budget? CAVE is a little bit broader in the sense of it's looking at its cost as an independent variable, so you can look at that trade-off. So I'm not necessarily limiting myself to $100 million or $10 million. I'm considering cost as one other thing to trade off. And so it could be that if I were to spend or limit myself to $100 million, I could be significantly limiting what I can achieve. But if I'm willing to spend, if you do this analysis and you see this, you might be able to see that if I'm willing to spend $120 million, I might get a significantly much more capable system. So CAVE is a little bit better in that sense, where it really opens the aperture a little bit wider and allows you to see the real trade-offs there.
Thank you. Let's see if we have more. I think we've gone through all of them. Let's see. So it looks like we've gone through all the questions that have been entered in the Q&A. So if you do end up having, more questions after we close today, you're welcome to email them to us and we'll be able to address those. Our next live session will be November 16th at 10 a.m. and 1 p.m. Eastern. You and your colleagues can register for that right now at the galarath.live site. And don't forget, there is a link in the chat right now that you can fill out the exit survey and you can give us your feedback and you'll be entered into the contest for the $100 Amazon gift card. And that's about it. So thank you everyone for attending today. Thank you again, Dr. Smart, for your presentation. And we hope you all have a wonderful day. Thank you.